So today we're going to continue on from what you did in class, assembling our trainer panels. Hopefully you should all have your panel looking about like this. You guys focused mainly on getting the push buttons mounted, toggle switches mounted, the potentiometer, then we mounted the DIN rail, and you don't actually have those on there yet necessarily. Some of you did get all your terminal blocks installed, but the second group especially, we kind of ran out of time for that. So I want to start by going over what you need to do if you don't already have the terminal blocks installed. So we did go over the wiring diagram, just how we would figure out how many terminal blocks we would need in a particular application. And so based on that, I sent home, I think, 2 red, 2 black, 6 gray, and 6 blue of these terminal blocks that you're going to use here for connection to the I/O panel. So the first step, if you need to do this part at home, is to install one of these. They're in brackets. They're used to keep the blocks from sliding along the DIN rail. So you just slide it on over, back just a little bit from the end of the rail, and then tighten it down. So and it just has a metal clamp on the bottom of it instead of, and you can see that here on this one, there's this metal clamp that grabs the DIN rail, different than the terminal blocks that just have plastic clips. Okay, so once we have that end bracket on nice and tight, we'll start putting our terminal blocks. And we're going to do a black one first for our DC negative, then we'll do a red one for our DC positive. And just kind of as we're going along, I'll squish them up to the side. And then I'm going to start just alternating blue and gray. And the blue and gray, the actual, I think I talked about this in class, but it's not so much that the colors are representing different functions here. Just if you have a row of all gray blocks or all blue blocks, it can be very difficult to keep track of which wire, if you're feeding your wire into the terminal block that you're tightening down with your screwdriver. So we just alternate the blue and gray ones for that reason, so that we don't get confused. So let's see, how many have I got there? 2, 4, 6. So I'm halfway there. So 8, 10. Okay. 2, 4, 6, 8, 10, 12. I think that's what I sent you for that. And then we're just going to put a black and red again at the other end, so we have another positive and negative, easy to get to. Pull my wires out of the way. Okay, so I've got all the terminal blocks I need for now. Then I'm going to take one of these end covers. If you're looking at the terminal blocks, you can see on one side the metal contacts are exposed, so we put this separator plate on the end to keep that safe. In reality, since we're putting these brackets on, they are kind of doing the same function, but just good practice to get used to doing that. So I will snap on my end cover and put on another end bracket. Slide that down and kind of push them together, make sure they're nice and tight, and then tighten down the end clamp. Okay, there is our first step of terminal blocks. So our next task is going to be to mount the DC motor. I've already mounted the metal bracket for it, and you should each have one of these DC motors. Yours will have wires already soldered onto the terminals, and then the wires will be kind of bent over and zip tied, wire tied to the body, so that if you accidentally pull on the wire leads, it's pulling on the frame of the motor rather than the terminals themselves. So I want you to orient the motor so that your wires come out of the back and are zip tied on this side of the motor, so it'll be easy for them to connect to whichever end of the relay we want, rather than coming out this side towards where the stepper motor will be in the future. So this is a little bit of a challenging task for a fat-fingered person like myself, but go ahead and get one started at the top first. Probably is going to be the easiest option. And although it's a Phillips screw, your little screwdrivers I sent home with you, flat bladed ones, should work for these small light duty screws. So there we go. Get one started. And then the next one's going to be a little bit harder because you kind of have to fit your screwdriver through the wire duct. So pick another one. I'll try this one over here. Actually, I probably should have done these two screws 180 degrees apart. But we'll try getting that one on there. And there we go. So go ahead and tighten both those down. And don't tighten them too tight since you're using a flat bladed screwdriver on a Phillips head there. But there won't really be hardly any torque on these motors. They're not actually getting connected to any load. We're just going to be turning them on and off, forwards and backwards. Okay, so once you have two in there decently tight, you're done mounting the DC motor. So we've got our terminal blocks installed, and DC motor installed. Let's talk about our next task. The next task I'm going to have you do is going to be to wire up the power supply. So I've already connected the 110 volt supply to your little 24 volt DC supply, but now we need to get that power supply usable for the rest of the devices in here. And previously, in your MEC 231 trainer, we just had it so whenever power was connected to it, it was on. There was a fuse built into the base, but there was no switch to switch power on and off. In this case, we're going to use this circuit breaker that's here on the left as both a circuit protection device, which is what it's designed for, and also just as an easy way to turn the DC power on and off. So the 110 volt power will still always be on if the plug is plugged in, but we are going to switch and protect the output. So let me pop this off the DIN rail so you can see it. You each should have one of these on your board. It is a 2 amp circuit breaker. So the output of our supply is 1.6 amp. So it's going to take a little bit more than that to trip it. And if you look on the side, you can see that line is on this end. That's the supply to the circuit breaker. And then load, that's the output from the circuit breaker. So you don't want to hook up your power in on this side and your load on the other, then it wouldn't be protected. So we want to feed it from the top, take the output off the bottom. So snap it back on to the DIN rail, lock that back in, and now it's mounted again. So we need to bring our DC positive from the terminals on the output of the power supply, and we're going to bring them around through here so that it's feeding the top of the power supply. And so I'm going to use red for that. So I'm going to take some of my red wire here, and I'm going to strip the end of it. And I'll twist the end of it to keep it from fraying. And then I will put it into my supply there. And go ahead and tighten it down. Be careful when you're tightening any of these terminals here. They are just flat bladed. So if you are not pushing down hard enough while you're rotating, you will strip out the head of the screw, and they're non-replaceable. So you don't have to tighten them super tight, just nice and firm, but make sure you're pushing both down while you rotate. Okay, and then I'm gonna stick it through one of the slots here. Try to kind of shape it nice there, and then just lay it in the bottom of the channel. Bring it around to where it will reach the circuit breaker. Cut it to length appropriately. It's better to have a little extra than to be short. So cut that off with your wire strippers and strip it. Twist the wire again and then feed it under the terminal. And you can see what I did there. I didn't twist it enough. I don't know if you can see, but I have a little whisker, so I need to pull that back out and twist it better. And this is one of those, is a great example of why we would prefer to put ferrules on the end of it. And if we were actually building a control panel, we'd be sure to do that. But like I said, the strippers are too expensive to be sending a set home with everybody. So we are just going to do the best we can, twisting the wires together tightly. Okay, so I've now got DC positive routed from the output of the power supply up through the circuit breaker, and now I'm going to come out the circuit breaker. So this terminal will be the one that's switched by the output here, and I'm going to continue on using red because it's still DC power. It's just switched now, and I'm going to cut this one before I lay it in. So it's going to come out of there and just kind of right across here. So it doesn't need to be very long. Twist them again. And I would like you, as part of the assignment for this connection here today, to look up the specifications for the circuit breaker. I'll post the part number for that. For the terminal blocks and for the power supply. For each of those, look up and see if you can find what the strip length, how much of the jacket they want you to strip off the connecting wires here. Okay, so now we're good there. Come in here. And now this is the first time we're landing on the terminal blocks. And the terminal blocks, you can see there's a row of screws that you're going to use to tighten up and loosen down from here. And then you feed the wire in through the slot on the side. So looking at it more up closely, that's where you tighten with the screw, and you're feeding the wire down that throat right there. So you can go on this one here. Hold the wire in while you tighten it down. Okay, I'll move that over so it's laying nicely. And there, we've now got the positive, comes out of our DC supply, runs around to the circuit breaker, comes out the circuit breaker to our red terminal here. Then we'll take another length of red wire and go across and come to here, so that will then turn these two blocks into places that we can land or anything that needs positive DC 24. For the negative part of the power supply, we don't need to switch that or protect it because the current protection on the positive supply will automatically, we can't get current coming out of the positive that doesn't go back through the negative. So just circuit breaker on that is good enough for what we're doing today. So now I'll use a black wire off of the negative, and it's gonna run down. Okay, and so things we're looking for as we're doing this, maybe a little hard to see, but you want to check each time you put something out that you don't have a bent over whisker of the wire coming out, or that you haven't stripped too much so that you have uninsulated wire sticking outside of the terminal enclosure. And we're fine here with that. So we'll do the same thing we did before. Bring it down over here. Okay, so we now have DC 24 volts on this end. Let's run jumpers down to get it down on this end as well. So I'll do the red end first. So I'm twisting it by itself, and in the future when you're doing this and know you're going to have multiple wires, it'd be most efficient to just have done this in one step instead of landing that red wire and now bringing another one to it. So now I'm going to twist these two together just to help hold them together as I slide them into the terminal block, and then tighten it back down. And after each time you tighten a wire into a terminal block, it's good practice to then tug on the wire to make sure you actually got it. And especially when you have two wires landing on one terminal block, I'll tug on both of them to make sure they're both well seated under the screw terminal. Okay, and then we're bringing it down to this end. Tug on it. Okay, so we've got that. Last one for now. For this part, let's do a jumper of the black. And hopefully you may notice I am trying to, when I'm stripping wires, I'm doing it away from the PLC or any other sensitive electronic components. If you're looking at the side of the PLC, you'll see there's cooling slots on the top and at different locations, and you don't really want a little piece of wire insulation, or worse, one little wire strand to get flicked into those slots, because that'll wreak havoc later on and you won't be able to figure out what's going wrong with your PLC. Okay, that looks good for now. We now have our DC power supply, 120 volt in, power positive comes out, runs around to the top of the circuit breaker. Circuit breaker protects it and gives us a switch to turn it on and off. Then we come out of there into DC positive and negative and jumper across to those. So we'll call that good for the power supply task. So the next wiring task for today is going to be landing these wires that are soldered onto the bottom of the switches, toggle switches, etc. We're going to land some of them onto these terminal blocks. So to do that, we're first going to remove the panel so that you can have better access to them. Don't lose those little screws if you can help it. Okay, so if you look at the bottom here, we're not going to do anything with the potentiometer today. I will post as part of the assignment a wiring diagram showing which wires are going to go where, but I just wanted to look at it here together. So in class we did that exercise of figuring out which wire was the common, which was connected when the toggle is up, which is connected to common when toggle is down. Some of you did the same thing on the push button to figure out which is the common, what's normally open, what's normally closed. So as I said in class to one section, I can't remember if I got it to both. Long term, we will want to kind of bundle these into a nice, neat kind of wiring loom that is something more like this, instead of loose. But for now, since we're going to be changing things throughout the term and adjusting what connects to where, I don't want you to cut any of these wires to length. The only thing we're going to do is strip the end of the wire so that we can land it under a terminal. Do not cut any of these shorter than they are now, because we'll need flexibility into where they land on terminal blocks in the future. So for example, I'm just going to do 3 of these wires here as an example. And these ones looks like are already stripped. They must have been ones we used when we were testing out the configuration of the switch. They look like they're probably stripped a reasonable length. You will know what a reasonable length is by this point, because you'll have looked up that part number and figured out the right length of jacket to strip. Okay, so I moved my camera so that you could actually see what's going on down here better. So I've got those wires that we just verified were stripped. I had you take this off because you can see if this was still screwed on here, it would be very difficult to get your fingers down in there to connect these. So the goal is that by the end of the term, we will have these all laid out and landed on these terminal blocks, and we'll actually add more terminal blocks before the end of the term, so that these ones will land on this side, and then they will just always be connected to that. You will only make your connections between push buttons and other devices on this side of the terminal blocks. So right now I would say probably best would be to set this kind of against the feet here like this, and then we're going to take the 3 wires that we're going to be landing and again check that they're twisted nice and tightly, and then I will give you a wiring diagram that shows the terminal blocks here, and I will list what you're going to connect to each one of those based on, I'll tell you the description of it and its color code. So for example, we would call this toggle switch 1, and we know that the common of that is the brown wire. We know that the signal wire, when the toggle is switched up, it's the yellow wire that's connected to the common brown wire. When the toggle switch is down, we know that common is connected to the purple wire. So I will just label those as common, toggle 1 up, toggle 1 down, etc. Okay, so if I were going to be landing these wires, let me grab my screwdriver. You'll follow the order that I give you, but for now I'm just going to pretend that I said terminal 1 should be the common of toggle switch 1. So I'd land that on this blue one. And this is where I'm saying that why I have the blue and gray, right? So if I was feeding in a bunch of different wires here, and I would, sorry, let me loosen that up and get the wire in there the right way. It can be very hard to make sure that you are sliding the wire into the same slot that your screwdriver is in. So tighten that down. And then again, always give it a little tug. Okay, so there's the brown one. Then let's say I wanted to do toggle up next, which I've said is the yellow one. Make sure it's twisted. Make sure I push it all the way in, and tighten that one down. Oops. There we go. And then next will be the purple one. Give it a little tug. Okay, so I've landed those 3, and then you would just continue on doing that for all the other ones that I show on the diagram. Just as a reminder, that won't be all the wires that we have on our board right now. We're not going to connect the potentiometer. We're not going to connect the orange lamp. I think our diagram we said would just be 1 toggle switch, 2 push buttons, and actually maybe I said 3 push buttons and 3 lamps actually, so we might do the orange push button, but you get the idea. So look for the drawing of the wiring diagram with terminal blocks and land all the wires that I direct you to on there. Once you have them all landed, tuck the unused ones that we're not connecting off to the side, and then reattach your panel with screws. And that'll be it for this part of the wiring. Good job. So I will post this wiring diagram as a separate scanned PDF for you so you can see at higher resolution. But I just wanted to show you what the diagram you're going to be working from is. So you can see across the top we have your terminal blocks 1 through 16. And you can see we've already connected our DC minus, DC plus, DC minus, DC plus. So the top side for this part is done already. Now you're going to land the wires on these next 10 blocks here. And let's just look at, how about we look at switch 1 as our example. So switch 1 here on the diagram is our red push button switch, if you're looking here, labeled switch 1. It's also labeled I1 for indicator 1, or lamp 1, LED 1. Basically, you can see there's two labels here. S1 is for the switch contacts, I1 for the lamp. And so if we look at our diagram, we'll see we have S1 here, and we have I1 here. And so the colors and whatnot for each of those are in two different spots. So for switch 1, if we look at it, it looks like it should have a gray wire, it's saying, that's going to land on terminal block 2. So you'll see that the gray wire from S1, the gray wire from S2, and the gray wire from S3 are all going to land on block 2. So looking now under here, you can see that the gray wire is basically the rightmost wire on each switch block. So you would take this wire, and this wire. You would strip them all to the same length, twist them together, and then land them on terminal block 2, I said. So they're going to land on the positive DC. So those three will go together, and I'm fine with you landing up to 4 wires probably on a single terminal block for this class. Then looking at the other side of the switch, the other side of S1 looks like is going to land on terminal block 7, and it is the brown wire. So if we look at switch 1, there is the brown wire from switch 1. So I would land that on terminal block 7. Let's look at the lamp for that same physical device. It's two separate electrical devices, right? The brown and gray wires are the contacts, and then the black and the red wires are for the LED for that one. So if we look at indicator 1, you'll see it has a red wire that's going to land on terminal block 10, and it has a black wire that, along with the black wires for indicators 2 and 3, is going to land on block 15. Okay, I think that's enough about that. Go ahead and land all your wires across there. Thank you. So that is actually all we're going to do for wiring for today's assignment. I'm going to post this one today on Thursday. I'm going to update it tomorrow with another demonstration of the connection from the terminal blocks to the PLC. But I want to wait and have you guys do that in a chunk so that you have the opportunity to first do the I/O part, get familiar with that before you do the terminal block to PLC connections. As the last time I did a couple hour long video, it was troublesome for YouTube, and I think it overwhelmed you guys a bit to do it in one shot as well. So I'm posting this first phase tonight, and I will post the second phase about connecting between these terminal blocks and your PLC tomorrow. So watch for that. Thanks.